Alright guys, this is the recording for phase change 1.3. And so what we're really focusing on is the different states of matter. So we have our solid, liquid, and gas, but we're really looking into the molecules and how they are structured in these different phases and kind of how these phases change from different ones, like how a solid becomes a liquid and a liquid becomes a gas and all those things and what causes that change. And so you can see here the assignment is linked. And you can open that. And then when you open that, scroll up on mine, you're going to see the first thing here is a warm up. And so the idea that we are looking at is Titan, this moon of Saturn, and there are seas and lakes on this moon made of liquid methane. And there was this lake that disappeared. And so thinking about liquid methane and liquid water, we know they're really different, but they have things in common. So what are two things that all liquids have in common? And I put this little picture down here because we can see this liquid water and we know water is made up of molecules, but we can't really see those with the naked eye. And so I want you to think about liquid water. Think about containers, how it takes the shape of whatever container it's in. And think about the movement of these molecules. How are they moving around? Are they moving at all? Things like that. There are two demonstrations down here that I wish we could do in person, but I found YouTube videos. So this one is a condensation demonstration. So I want you to watch it and observe what happens. Observe that phase change. What do you see happening? And I want you to also think about the molecules. What is happening to those molecules? Hello, cat. I also want you to think about temperature. How does temperature play a part in these different phase changes? And there's also one on evaporation down here. Because think about evaporation, think about a puddle if it just rains outside. That puddle doesn't stay there forever, it evaporates. And what usually is causing that evaporation in our sky? I don't want to give away the answers, but you know. The next thing is the simulation. If you open up the simulation, you will see that there is a few different things. The other thing that I did was in class, I showed a couple of these slides. One of the slides shows a intro video on the simulation, which you should watch to get you some ideas of how to work the simulation. You might have remembered it from last year. But this is kind of the idea we're focusing on right now. So macro scale versus molecular scale. So macro scale is what we can observe with our eye. We can observe the liquid water and see the water in the cup. The molecular scale would be all the molecules that we can't see. So we know that the liquid cup of water is made of molecules, but we can't see them. And so those are things that are going to be too small for our eye to see. We have scale, which we know is the relative size of things. Molecule, which is a review from a previous unit, so our atoms join together in a particular way. This is the image I showed y'all last time to kind of show you how these phases go back and forth. Solid melts to liquid, liquid evaporates to a gas condenses to liquid, liquid freezes to solid. So it's a really important image to kind of solidify what we're doing. And then on slide, I think it's 17, maybe 18, this one. Here is a video, so it's the one with the purple background that kind of goes through some of the tools in the simulation. And so when you get into the simulation here, looks like it's redirecting me. All right, here's the simulation, and you can see that there's different substances, and it doesn't tell you what state they're in, but you can have an idea. We talked about how the molecules are structured in different states, and you can see that all four of these substances are starting in the same state. And so this is solid. In a solid, all those molecules are structured, they're stacked on top of each other, they're close, they're not moving. But as soon as I add some energy and some temperature, notice how they start to move a little bit. That would mean that they changed phase. And if I bump them or rotate them, Think about a cup of water. Obviously, if I move my cup of water back and forth, that's going to flow that way. And then if I continue to add energy and temperature, I'm going to change that phase again. If I get past a certain temperature, you can see some of my molecules start to escape to the top, even though I have a high level of attraction here. That means that they are attracted to each other and kind of sticking together. If I go on to my substance C here, you can see those molecules start going all over the place, and you can click on one and kind of watch it go. And I just pretty much simulated phase change from a solid to a liquid to a gas. And so you can do that same thing and be able to answer down here, this table. And so I gave an example down here with my last class. We have our three phases, gas, liquid, and solid. And then we have the macro scale appearance, which is what we can see with our naked eye. So we know a gas will fill the container and has no shape. And we can't really see it, but we know it's there. Like, I know this room is full of gas right now and it fills the room, but I don't see it. And then you need to talk about what the molecules are like in the gas. And we saw them kind of flowing around freely. They move kind of fast, things like that. Then the next one is liquid. And so we know that liquid flows, it stays at the bottom of a container and it takes the shape of whatever container it's in. So on the simulation, what did the liquid look like? They're flowing. They kind of stayed at the bottom. They were moving, not super fast, but there was movement. And then obviously our last one, our solid, it's rigid, it takes keeps its shape, excuse me, and the molecules are stacked together and they're not moving. And then using that information that you got from the simulation, there are 3 claims down here. And I want you to pick which claim you agree with. And then kind of use some of that evidence that we saw in the simulation to explain why. So the first claim says that molecules in a substance disappear or no longer exist when a substance changes phases. And they think this is because when a substance goes from liquid to gas, it can no longer be seen. So do you agree with that? Yes or no? Claim 2, they think the molecules in a substance move differently when a substance changes phase. They think this because when you tilt the container they're in, a liquid, gas, and solid don't move in the same way. Okay. And then the last one is that they think the molecules in a substance change into a new kind of molecule during phase change. And they think this because liquid looks different from solid or gas. So which of those 3 claims do you agree the most with? And then down here, oopsie, you're going to tell me what you noticed from the simulation that will support. And you can continue to play with the simulation more if you need to gather more evidence. And then there's a scenario down here that I want you to read and kind of tell me what happened with this rain puddle. And that's it for this lesson.